Yes, we can hear you.
Yeah. Am I audible?
Yes.
You are audible.
Yes, sir.
Okay. Hello, everyone. So, today we have Aniruddhan sir with us. Anirudh, Aniruddhan sir is a second year PhD student in statistics and operations research at the University of North Carolina at Chapel Hill. He loves exploring how randomness shapes the world through his research and stochastic modeling and casual inference. When he's not diving deep into data or mathematical ideas, you'll probably find him or uh, badminton court, like he's a enthusiast also, and he likes to play badminton, or out on a hike or long walk also, lost in thought or in a great conversation. For him, math isn't just a subject, it's a way to understand how everything connects to the world, and how we use mathematics in our real life, and and shaping our future. So I'm take over to him, and all the best to sir for the lecture.
Awesome. Thank you so much, Prathamesh, for the lovely introduction. And I know it's been a very long camp for you guys. I think today is the last day I've had, so I'll keep it a very relaxed session, hopefully. And yeah, hopefully do intend to engage all of you, and hopefully it's a fun session. And all right, so let's get started. I'm going to talk about something called the mystery of why. And I hope a number of you have at least questioned why I named my slides the mystery of why. So to answer some of your questions, I'm going to talk about, let's get started, right? So, okay, I'll start with one example. So one very specific, very interesting example that I found was the following. So imagine the following scenario where I'm plotting two things. One is the number of deaths by drowning, and two is the ice cream consumption in kilograms in Spain in 2018 as a whole country, right? So I'm looking at this plot over time. So this Jan, Feb, March, April, and so on. The blue line, let's say, is the number of drowning deaths in Spain, right? So as you can see, it starts off small in January and February. The number of drowning deaths is close to maybe 30-ish per month. But in the months of May, June, July, or August, the number of drowning deaths suddenly moves to 110 or 100 around, right? And then it falls back up again as time progresses towards November and December, right? So now similarly, let's try and plot the ice cream consumption per month. So here, the ice cream consumption is very low in January or February or March. It's about 3 million kilograms. That's what the axis on the right is about. And in May, June, July, and August, it reaches to close to again 100 million kilograms. Sorry, 28 million kilograms. And again, in October, November, and December, the ice cream consumption reduces back again. So I want you to think about whether this question makes sense or not. Do you think that ice cream causes drowning? Would you agree that if I told you ice cream causes drowning? From the picture, it appears to be the case that if the ice cream consumption increases, then drowning also increases. And if the ice cream consumption decreases, the drowning rate also decreases. So, what do you think we can say about ice cream consumption causing drowning? So, raise your hands, and probably the hosts can help me unmute them one by one.
Madhusudan?
Yes. Sir, I feel that ice cream consumption is not the cause for drowning, and I have my reasons for that.
What are they?
Okay. So first, as as March, April, May are the months of summer, people would want more cold items to eat, drink, or, for example, or swimming. So, so ice cream consumption has increased from 3 million till 28 million. But and drowning as June, July, August, and September are the most rainy, are very rainy months of the year. Or what should I say? The monsoon months of the year.
Mhm.
It the water levels would have increased a lot by then. So the rivers would have been flooded, etc. The oceans they would have increased. So thus there had been more drowning deaths.
Excellent. I really like that answer, right? So, okay, so maybe like one small correction that I would make is Spain is slightly tropical in climate. And so there is going to be like a mixed effects of summer and rainy in the months of May, June, July, and August, right? So maybe I'll take it. Thank you so much for your answer. But let's take in one more answer. And one thing I should preface before that is I'm going to be asking you a lot of questions, right? So even if you did not get to answer a question up in the front, don't feel dejected. You're going to have a lot more options to answer your questions, right? And maybe one request for the volunteers at this point would be to preferably pick new people who haven't answered before in the subsequent questions. So maybe let's take in one other answer and then we'll press on and ask you more questions.
Sure, sir.
Okay, Kamal, would you like to answer?
Hello, am I audible?
Yes, you are.
Yes, you are audible.
So, sir, this doesn't make any sense that eating ice cream is causing drowning because in the summertime, ice cream would obviously the sales will go up, and in that time the level of water is also going up, so the chances of drowning is also increased. So
Why
it
would you
doesn't
say
make
that
any
in
sense.
summertime the level of water would go up? That doesn't seem very intuitive, does it?
Uh, let
Maybe
that
explain summertime.
drowning is another thing, and the selling ice cream is the other thing. It
Sure.
doesn't have any relation.
Sure, excellent. Right. So, what? Okay, awesome. Thank you, Kamal, for your answer. Right. So, one thing that appears to be the case is the following. So, somehow we've established, based on your answers, somehow we've established that temperature is one of the main causes for drowning. Right. So, if temperature increases, I would want to eat more ice cream. That's why the ice cream sales is going up. And if temperature increases, I would want to go swimming, let's say. And if I go swimming, there are higher chances of drowning, right? This is not to push you against swimming, but it's just a statistical fact, right? You can't drown without swimming.
So just a
And
doubt. Uh, does the 120? What is the units for the deaths? It's just 120 people, or
I believe so. I believe it's 120 in the whole month, for instance,
oh, okay.
in the whole month in the whole country. Yeah. Yeah. Okay. Thanks for the question, though. Right. So one way to rephrase my question. So my initial question was, does ice cream cause drowning? One way to rephrase it would have been that if I banned ice cream, do you think fewer people would drown? This clearly does not make sense. Right. The answer to the second question is going to be no. Right. So one thing that we've established is the following. Just because two things behave very similar to each other does not mean that one has caused the other, right? So the statistical or the mathematical way to say that is just because two things are correlated, that does not mean that one thing has caused the other. Because just based on this picture, I could have asked the opposite question also. That is, do you think drowning is causing people to eat more ice cream? That clearly does not make any sense, right? So, one of the key points that I want you to take away is that correlation and causation are very, very different things, right? Right. So let's keep on doing some more examples and then hopefully you're even more convinced, right? So let's look at the following plot. So this is a plot in Maine, which is a state in the northeast of the US, right? So I'm going to look at over time, over a period of 10 years, I'm going to look at the number of divorces per thousand people in Maine. In other words, I'm looking at the divorce rate in Maine So a divorce is when marriage ends because the two people think they're no longer compatible, etc. And on the other hand, I'm also plotting the pounds of margarine sold per person. Think of this as the number of kilograms of butter consumed per person per year. Right? So one thing that's clear is the following. So in the year 2000, the number of divorces was very, very high. It slowly was decreasing until 2005. And then there appears to be a slight increasing trend again, right? And similarly, if I look at the red plot, which is the number of kilograms of butter consumed per person per year, it also appears to follow a very similar trend, right? The butter consumption is decreasing until 2005, and then there appears to be a slight increase and then a decrease again, right? So you would agree if I told you that these two graphs are also very highly correlated. By correlated, I just mean that they behave very similarly, right? And okay, answering your question, yeah, margarine is butter. Thank you so much, Bhairav. Right. So now so now put your answers in the chat. Do you think any one of them causes the other? Do you think people are getting divorced because they're eating more butter? That seems a really stupid reason. Or do you think people are uh, eating a lot of butter because they're getting divorced? Does any of this make sense?
Sir,
No?
Madhusudan had a doubt about something. Madhusudan, can he ask the doubt?
Yes, sir. The doubt is on the previous question,
Sure, what's up?
the ice cream murder mystery. Um,
Okay.
if I think if ice cream is banned, more people will go for swimming, which will cause even more drowning.
I love that answer. Wonderful. I've never thought of that.
Isn't
I,
that
I think I have to agree with you.
isn't
I
that
think
true,
I
sir?
have to. I have to agree with you. That's a wonderful answer. That's a wonderful way to think about it. Awesome. I like your line of thought.
Thank you, sir.
Super. Okay. So awesome. Okay, so let's come back to our example here. Awesome. So I see a lot of no's in the chat, right? You're right. Right. So these two appear to have no real link between each other. Right. So this is what statisticians would call a spurious correlation. In other words, I mean, just because there is a lot of data available, I would expect two things to behave similarly without really one having caused the other. Right? So this is what a spurious correlation is, right? So tying these two examples back together, what we're really interested in is based on just data, how can we identify the fact that one thing has caused the other, right? And we don't just want to say that one thing has caused the other, but we also want to, in some sense, be able to quantify how much the change in one of the quantities has led to a change in the other quantity, right? So this is what the whole idea of this branch of statistics called causal inference is about. In other words, what we're trying to do using causal inference is just based on the data. We're trying to see how much was the effect of the cause on the outcome. We're trying to come up with ways to quantify this effect, right? So let's do one more example before we move on to some more slightly interesting um, points to talk about. All right. So this is a slightly weird graph with time going backwards from right to left. Right. So this is not a usual graph, but I like it for one very specific reason. So imagine plotting the following. Look at the global average temperature on the y-axis, right? So in 1820, the global average temperature was close to 14 degrees Celsius, and it's been slowly increasing. And the average temperature is around 2000, sorry, in the year 2000 is around 16 degrees Celsius, right? And maybe let's also look at the number of pirates, right? So the number of pirates in the world per year. This is an approximate of this. I don't know what the units in the x-axis is though, but yeah, it seems believable. In the year 1820, there are many, many pirates. There are close to like 35,000 pirates, and then this should have been 30,000. But in 1860, this reduced to 30,000. In 1880, it reduced to 20,000. And all the way in 2000, there are believed to be only 17 of them, right? Now, do you think if somebody wants to come up with a solution to global warming, let's say based on this picture, I propose that we can train more pirates. It appears to be the case. as the number of pirates decreases, the average temperature of the world is also decreasing, right? So would it make sense to train more pirates as a solution to global warming? What are your thoughts on this? Raise your hands and I'll ask you maybe like one or two people to answer out. Again, volunteers, it's up to you now.
Okay.
Yes, Nandita.
Will not make sense to train more pirates because at that time, fossil fuels factories, those things were less, which did not, which caused the Earth's something, which caused the Earth's ozone layer to be intact and global warming to not happen as much. And at that time, pirates were also more, as that was the golden age of piracy. Now that there are more factories and industries or something, it's not so much now, but pirates have gone away because it's just not their time anymore.
Excellent. I like that answer, Nandita. There's one more person want to answer before we slowly press on. Thank you so much.
I think Asma wanted to say something.
Yeah, I just had a similar answer to her. It's fine. I also
Okay, do you want to rephrase that answer? Rephrase
Okay,
it in your own
okay,
words.
okay.
Asma, can you rephrase your answer in your own words?
Yes, Malolan.
okay. Uh, I don't think training more pirates will help bring down the global warming or the average temperature because
Okay,
they're completely unrelated. And
sure.
yeah, because in the previous years, the global warming wasn't that much as there weren't any factories, and the pirates before were more, but now not many of them are there because
Excellent. I
it's
like your
not.
answer, Asma. So, awesome. So, one thing that we've established is that time seems to be one major thing, right? So, with time, the global average temperature is increasing because of many other reasons like industrialization, etc., like Nandita pointed out. And it also appears to be the case that with time, the number of pirates are decreasing, right? And this could be because the security measures have gone up and surveillance measures have gone up and so on, right? So, in other words, for two specific things, there need not just be one single cause, right? So industrialization has caused my global temperature to go up, and something like surveillance and security methods getting better is causing my number of pirates to go down, right? So, in other words, there need not just be one specific reason that, in some sense, causes two things to occur at the same time, right? So, one of the main things that I want to point your attention to is something called a confounder. The idea of a confounder is like a quantity that affects both my variables that I'm trying to study, right? In this case, time is going to be one major confounder because time affects average temperature. Time also affects the number of pirates in its own ways. Not establish any causal relationship between the two variables. And here again, temperature is one major confounder because temperature causes both drowning deaths and an increase in the ice cream consumption, as many of you pointed out, right? So let's do some more examples. And it's going to be very quick examples. So again, volunteers, you should be on your toes now. I'm going to expect some responses here, right? So let's say children with larger feet tend to read better. I want a quick explanation for do you think children with larger feet would read better? Is this a valid causal statement to make? Okay, one person.
Yes, Malolan.
It makes a little sense, but it does not make too much sense because children with larger feet means maybe they're older, so they read
Wonderful.
better.
Wonderful. I like that answer, right? So what is your confounder here? The confounder here is simply age, right? So let's do one more example. And let's say lower your hands now, and then you can re-up it again, right? So now let's say the more the fighters, the more the damage. Let's say there's a fire, and there are way too many firefighters, and does that mean there's more damage? So now a question that I would ask is, do you think the firefighters are causing the damage? So what's your answer to that?
Abhyutya?
My answer is it's not the firefighters that are causing the fire, rather, more than firefighters will reduce the fire, but the position of the fire at that state is dangerous.
What do you mean?
Means the need for more firefighters is that there is more fire.
Exactly. Right?
Yeah.
So in other words, if I have a very large fire, I would need more firefighters. And if I had a very large fire, I would also need more damage, right? So the size of the fire in this case is a confounder, right? And so maybe like you can do a couple of other examples, like things like areas with more doctors have high chocolate consumption, which is again very weird to think about, right? And in this case, it's been seen that wealth is one major confounder. So in an area which is really wealthy, there I would expect a lot of doctors to be there. And in an area that is really wealthy, I would expect a lot of people to be eating chocolates also, right? So wealth is one major confounder in this case. And similarly, I can talk about the coffee drinkers and having a risk of lung cancer, right? And there have been studies that show that smokers in general tend to drink coffee. So coffee per se doesn't really cause lung cancer,
Coffee causes
but
smoke tend to drink
smoking
more.
tends to increase coffee consumption, which in turn causes lung cancer, right? So the idea of what's going on here is something called mediation, right? Or yeah, so you think of this as a confounding or a mediation in a very weird sense, because so in some sense we all believe or know that smoking causes cancer, and coffee is sitting somewhere in between this chain. Smoking causes an increase in coffee consumption, and so this in other words is simply a correlation because of its confounding with smoking, right? So these are some examples of correlations and not necessarily having causations, right? So in causal inference, what we're interested in, we are trying to understand the raw effect of what we think is the cause on the outcome. In other words, what we need to do is we need to control or balance out all the other factors that influence both the cause and the outcome, and only try to understand the effect of the supposed cause on my outcome, right? And so I'll just put out like this, one of the volunteers could possibly put out this link in the chat, and let's see if I can do that. Not very quickly, looks like. I can send the slides to you and you should be able to do that, right? So there are lots of examples of spurious correlations in this. I really had fun looking up at this link, right? Right. So now let's come back to what the main idea of causal inference is. The main goal is to try and understand what is the cause, what is the effect, and how much is the effect of the cause on the effect. That's a lot of causes and effects. But in other words, simply think about, let's say there is one quantity that we suspect is causing something else. We want to understand two main things. Is it really causing it? And if it is causing it, how much is the impact of it? Right? So these are the two broad questions that causal inference attempts to answer. Right? And so you might ask, what is really the use of this? Are you going to spend one full Sunday evening talking about ice cream and butter? That clearly doesn't seem very useful, right? So one of the major uses of causal inference is in the world of medicine pharmacology, where we're trying to understand the effectiveness of a new medicine that's been introduced, right? So let's take one very specific example. So let's say all of you are CEOs of a major pharmaceutical company, right? And let's say your team works on something, you and your team works on something, and you claim to invent a new medicine. Let's call it Remediox. And you claim that you can reduce fever twice as fast. So let's say in general, fever takes maybe 3 to 4 days to reduce. And let's say you've come up with a new medicine that claims to reduce fever in 1 or 2 days, right? And now my question for you is the following. You're the CEO of a company, and let's say I'm the World Health Organization, right? What I want you all to do is to think about how are you going to convince me that your medicine works? Remember, if you're trying to convince me, I'm the World Health Organization, right? I'm going to be really very strict. I don't want any fake medicines out in the market, right? And since I don't want any fake medicines out, I'll be really very careful to see what I allow in the market and what I don't. So you have to do a really good job of convincing me that this medicine actually works. So I want you to take a minute and think about how you're going to convince me that the medicine that you proposed actually works. I'm not asking you to convince me that this works, but I want you to think about how you're going to convince me that this works. Okay. So let's take a minute to think, and maybe like in maybe 30 seconds or so, the volunteers can help me unmute somebody.
Yes, Kamal, you raised your
Uh,
hand.
yes, sir. To convince you, I will just make call 100 people and give them other medications like ordinary drugs. Then for other 100 people, I will give Remediox, and after few days, I will calculate the data of which people are getting reduced fever or not. From the people who have taken ordinary drug will have mainly 4 to 5 days, but the people who have taken Remediox would may have taken 1 to 2 days.
Excellent. I like that answer, right? So what are we doing here? I really like that answer. But one question for you. Is it Kamal who answered? One question for you.
Yes.
How are you choosing the 100 people?
Uh, Maybe I'll be organizing a contest with a
O-
cash prize of something.
Okay. And how are you going to choose this 100 people? Be slightly more specific because there is one specific issue with this, right? So let's say I organize a cash prize. Let's say in let's say raising a mathematician, I go and organize a cash prize saying, if you decide to volunteer yourself as a trial for Remediox, then I'm going to give you, I don't know, 20,000 rupees, right? But if I go to raising a mathematician foundation here, what do you think is one slight issue in just going to raising a mathematician foundation and seeking volunteers? Can somebody else see an issue? Does
Yeah,
somebody else see a small
yeah,
issue with this?
Nandita, do you want to say something?
Yes, sir. So basically, I would ask a certain small range of doctors, perhaps
Mhm.
9 or 10, and I would ask them if they prefer this or that. It doesn't matter what kind of doctors they are. And if 9 or 8 of them answer, I say 8 out of 10 doctors or 9 out of 10 doctors prefer Remedial. Thus, you should buy this one.
That's a very Colgate type ad. I really like that. But again, I am not convinced about choosing any doctors, for instance. For instance, if I ask maybe like a psychotherapist or somebody, then their expertise isn't necessarily in infectious diseases or like fever control and so on, right? So it's not really expert opinion that you're getting. Do you see where that's going? So I would be
Yeah.
slightly more careful. So I am not convinced. I'm sorry.
Or I would bring
You
a
want to try
graph
again?
showing that the fever goes down.
With
I would just bring a data graph because fevers are already going down because it's not a dangerous thing anymore. And I would also
okay.
show Remediol to show that fevers are going down.
Interesting. Okay, that's a good way to go about it. I like the idea of using graphs. But let's come back to the point that, oh no, I forgot who the first person was. So one of the issues of maybe like incentivizing, or maybe like so one of the issues of going just to maybe like raising a mathematician foundation to get my sample
Sir,
is that I'm gonna
I
yeah,
think Kyra wants to say something. Like,
oh, sure, yeah, kind of.
sh-
Yeah, so what I was saying was that the one problem is that those 100 people need to have fever also. Like, how do we get them to have fever?
Sure.
Because
What if I force all of you to have fever? What if I give you all ice cream and make you have fever? And let's say, and then I choose 100 people, right? So let's say I am restricting myself to people who have fever from raising my meditation foundation. Hopefully, none of you. But even if I restrict myself to that, there is still a bigger issue. What is that?
Ayushi?
yeah, Ayushi.
I collect the data from hospitals whoever in same situations. Just I
Mhm.
collect 10 people. I make two groups of patients. Just in 10 is in same situations and 10 is same situation. Not each other is non one is serious from each other. And I give drugs of one group and another group ordinary groups. And if my if the group will take my drugs, he will better fast than ordinary group. Then my drugs also reduce fever twice as fast as any other medicine.
Good. Good. Okay, that is good. And nice. Thank you for the answers. I got one interesting answer on private chat, so I'm not sure if they want their name announced. But the interesting answer that I got is that I'm only going to sample children, right? All of you are very, very young. And if I only sample people from Raising a Mathematician Foundation, my sample in some sense is going to contain mostly school going children, right? So I may be, so if the drug actually works, so I can be convinced that the drug actually works for school going children, but it might or might not work for 60 or 70-year-old uncles, for instance, right? So that's one of the major thing that we have to be very careful about in choosing the sample, right? So your sample has to be diverse enough to capture how diverse the population is in real life. And I also have to take care of the way in which who I administer the actual Remediox medicine to and who I give another just an existing medicine, right? So that was one of the points that was brought about, right? So two major questions to ask is the following. So this was the idea that was proposed, right? So I pick 100 patients with fever, and let's say I give 100 people, I give 100 people Remedios, I give 100 people another a fever medicine. I don't know what is a fever medicine. Is Crocin a fever medicine? Let's go with Crocin, right? And let's say I conclude there are two things I have to be careful about. One is, what if the people who got Remediox were younger in general? What if the people who got Remediox were healthier in general, right? And it could also be the case that if I gave people the choice of whether they wanted to take Remediox or Crocin, what if things like sicker people avoided Remediox simply because it was too risky to take Remediox without knowing the unintended consequences, right? So in some sense, my sample who got Remediox could itself contain people who weren't very sick, and that's going to artificially say that my drug actually worked very well, right? So in other words, I have to be very, very, very careful about the way in which I design my experiments, right? So this is one of the main issues with causal inference, how I'm going to carry out my experimentative study in order to get the results that I want, right? So, what we should really be asking is, if the same person recovers faster if they took Remediox instead of Crocin, right? But obviously, I cannot test the two different drugs on the same person, right? So let's say, for example, I have fever. Once I have fever, I'm going to take Remediox, and let's say I recover in 4 days. Let's say I take Remediox and recover in 4 days, let's say. Right? Now, I cannot, I mean, it's going to be unethical to once I recover, make me get a fever again, and then give me Crocin, and then see if I'm taking 8 days to recover or not. That is a possibility, but that's a very unethical thing to do, right? Once you've made me free of fever, you don't want to give me fever again, right? So that's a very unethical thing to do. So we have to be slightly more careful in trying to understand how the effect of the drug is. And now one major question arises. Do you think we can answer this question at all? Is it even hopeful to be thinking about answering this question, right? So here is a thought experiment similar to what I said, right? So what if we could clone patients in a very interesting way? Let's say for every person in the trial, there is a copy of that person who's the exact same in all characteristics, right? So all their body chemicals, etc., the way they behave and everything is all exactly the same, right? So to one person, I'm going to give Remediax, and to the other person, I'm going to give Crocin, for instance, let's say. Now, this would be the ideal scenario in comparing the effect of the medicine, right? So let's call it maybe like Anirudh A, I'm going to give Remediax. For Anirudh B, I'm going to give the crocin, right? Than Anirudh B, then I'm gonna more or less conclude that Remediox works better than crocin. But there is one major problem with this. Does anybody see one major problem with this? Yep. Any raised hands again? Volunteers?
Malolan?
Yes, Malolan.
Sir, I just have one doubt. Uh, first doubt is how do we find clones? Like
Excellent.
clones, basically, we haven't cloned any human yet, and
Yep.
and then are we actually making a very good drug? Like, is Remedix actually a good drug, or are we just
Mhm.
do we know it's better than Crocin?
Awesome. That's a very good question, right? So coming back to your first, yet giving hope that there is still a possibility of cloning. So I'll point your attention to two stories here. Read about one called Dolly the sheep, who was the first sheep that was cloned. I think this was in the mid late 1990s. So cloning is possible. It has been attempted on sheep, but yet
Yes,
one
sir.
story.
Dolly the clone.
Yes, Dolly the clone is one very interesting story to read about. And yeah, so that's going to be one. And coming back to your second question of whether Remediox is actually better, that is what we are seeking to understand, right? But the question is, does this experiment convince you that Remediox is actually better? In other words, let's say I had 100 people, I made clones of 100 clones of these 100 people, and let's say all the group A's, I'm giving them Remediox, all the group B's, I'm giving them Crocin, right? And the question is, I'm going to compare the average recovery time in the Crocin group and the average recovery time in the Remediox group. And if this difference is sufficiently large, I'm going to conclude that Remediox is actually good, right? But as you pointed out, the main issue is in the fact that I cannot make clones anymore, right? So we are stuck in a world where we don't yet have the ability to make clones, and we have to deal with data as is given to us, right? So we have to only work with the data that we have without really having the ability to clone, right? So one workaround this is to identify two groups or two samples of my population that are very, very similar as much as possible, right? What I mean by that is, let's say in my experiment of 100 people, I'm going to find two groups of 100 people each in such a way that these two groups are as similar as possible. Let's say I take 15 students in each group, and I take, let's say, 10 people who are 85-year-old men in each group, five people who are, I don't know, 3-year-old babies in each group, and so on, right? In some sense, I'm going to force myself to make groups as similar as possible, right? One of the issues with making these groups is that I have to think about what the potential confounders are. That's why I introduced confounders, right? So remember, what is my experiment here? I'm trying to understand my effect of Remediox on the time that it takes to recover from fever, right? There could be multiple confounders. Age could be one confounder. The level of health of a population could be one confounder. And maybe just the environment in which they're sitting, whether they are the participants are in a village where they don't have a lot of access to clean water, clean drinking food facilities, and so on, or are they in an urban area, and things like this are major potential confounders, right? So it's extremely crucial to understand what the confounders are when you're trying to come up with or design an experiment, right? So once I have a good enough idea of what the confounders are, I'm going to try and make two groups that are as similar as possible in terms of my confounding effects. And to these groups of people, I'm going to give one Remediax, and for group two, I'm going to give Crocin. And I'm going to see if the recovery times are actually significantly different or not. And if they're actually different, I'm going to be convinced that my drug actually works, right? So this is one broad roundabout way of convincing the World Health Organization that my method actually works, right? So I'll pause maybe for a quick couple of seconds for a question. If you have any questions, please feel free to raise your hands. And yeah, awesome. So Malolan, I see a raised
Yes,
hand.
Malona.
Sir, so we don't know if our product is better than Crocin. So if let's say it's not better than Crocin, then we've actually of the WHO is not going to accept it as that convinced. They won't be that convinced. So so this experiment may lead bad for us. So wouldn't
What
it be better to not do this experiment, or if and do some different experiment that makes sure that we're better, at least
Oh
conveys
no,
we're better.
I really like how you put yourself in the shoes of an actual CEO and you're thinking more about profits than about actual health. I like that thought, but we are in a world where we want to be as fair as possible. In other words, I don't want to introduce a medicine that doesn't work. Does that make sense? Do you have a follow-up thought on that, Malolam?
Yes, I get what you're trying to say.
That's a very good thought. Right? Do I
Like
see some more? Yeah,
our medicine doesn't have to be that bad. It's just
sure.
we can just show that it's better than Crocin to at least have marketed better than Crocin.
Excellent. I like that thought, yes. But see, if I'm trying to come up with a new medicine, I am still going to incur a lot of charges in terms of its manufacturing and so on. The question is whether I would really want to bother with introducing this medicine to the world or not. So I would want to be very, very convinced that this medicine actually works before proposing it to the World Health Organization for a review. Right? Awesome. So, Madhusudan, do you have any questions?
Yes, sir. I have a question and something else to share, sir. First, the question is we didn't
Yeah,
discuss this, but what if Crocin worsen their diseases?
sure. Okay, that's a very good thought. The fact that Crocin has been approved as a way to treat fever means something like this has been done to conclude that Crocin is actually good in reducing fever. Does that make sense?
Yes, sir, I wrongly worded it, sir. What if Remediox worsen their fevers, not Crocin?
That's going to be worse for me. I'm going to lose my job as the CEO of the company. Right? This is
Okay.
one way to find out whether it actually works, right? But this is another thing that I want to point out. So when you're designing a new drug, for instance, you don't go about directly testing it on humans, right? You first have samples on rats or guinea pigs. You see if it has any unintended consequences, and only after that do you bring in trials on humans. And trials on humans happens in a very, very coordinated fashion. It happens in 4 stages, for instance. And at each of these stages, so for instance, when maybe the first set of people are getting Remediox, they're going to be very closely monitored by a set of doctors. In case they have any very adverse reactions that they weren't expecting, there are always going to be a team of doctors on call to quickly come up and alleviate the issue, right? So I like this thought. And yes, all right, that is good. All right, so Madhusudan, do you still have a raised hand?
Yes, sir, because I have to say one more thing, sir.
Sure.
What if Remediox is not exactly a medicine, but
Mhm.
it is something like if you mix it with the with the curing medicine you currently want,
Sure.
the process becomes faster.
Excellent. I like that thought, right? So you're getting into the world of identifying what the actual dosage of Remediox should be, for instance. This is a much more difficult problem to deal with. This is sort of, maybe I can tell you that this is sort of what I'm dealing with or what I'm doing broadly for my PhD itself, right? So one of the broad aspects what we're thinking about is the idea of something called precision medicine, right? So in precision medicine, what we're attempting to do is we're trying to understand for each patient based on the way they respond how much is the dosage I should prescribe for that patient, right? So in some sense, I want to be able to individualize or tailor prescribing medicines to a patient based on their genetic factors, based on their medical history, based on the way they've been responding to other treatments, and so on, right? This is in general a much more challenging problem than just trying to figure out whether this medicine works or not, right? So what your point, it asks a lot of other questions. So let's say I'm testing whether just crocin is good or the combination of crocin plus remediox is good. Now, this opens up a lot more questions as to what should be the correct ratio of crocin plus remediox, right? Now, instead of a yes no problem, I've now opened myself to a world where my problem essentially doesn't take just yes or no, but it asking me for what proportion of this, right? In other words, instead of having just two answer choices, I now have infinitely many answer choices, right? So this, as you can imagine, is going to be significantly a harder problem to ask and is the more useful version of the problem to ask, right? So press your thoughts on this. I really like your line of thought. And I can say that these are things that people are currently thinking about, right? These are exactly the kind of questions that people in biostatistics, etc., attempt to work on, right? So I love your questions here. Right. Let's slowly press on and introduce formally the idea of something called a randomized control trial, right? So this is sort of similar to what all of you have already answered. So think of this as my actual sample of maybe 200 patients, right? For each of these 200 patients, what I'm going to do is I'm going to roll a dice. If it comes out as even, I'm going to assign them to the treatment, and if the roll of the dice comes out as odd, I'm gonna assign them to the control group. By control group, I mean that I'm giving them crocin, and by treatment group, I'm giving them remediox. Right. So once I give this intervention, once I give them remediox, I'm gonna observe the outcome of how long it takes for them to recover. Right. So the bowling pegs with hearts simply mean that they've recovered in 2 days, let's say, and the bowling pegs without hearts, let's say it means they've taken 4 or 5 days to recover, right? And maybe like coming back to the control group, here is where I've given them crocin, and I see the following. I see that um, 4 out of 6 people have taken very long to recover, and 2 out of 6 people have actually recovered very quickly, right? So one of the key things that's actually puzzling here is this idea of using a die to assign what treatment to give, right? I have one question for you. What do you think is the advantage of flipping a coin or rolling a dice in order to decide which who gets which treatment as opposed to asking who wants what? So, for instance, let's say I recruit 200 people in the study, and the moment they get set foot in my hospital, let's say I ask them, do you want crocin or do you want remediox? So, what do you think the issue with that is going to be? That is actually going to be solved by rolling a dice in front of them. And if it's even, I'm going to give them remediox. If it's odd, I'm going to give them crocin. Yeah. Any new person who's not answered
Yeah,
before?
yeah, Sanjeev, can you answer?
So first of all of those 200 people choose Crocent because they were probably not like Remediox and will risk their life for it. Second of all,
Yes.
if you randomize it, you will have more exposure to people and a clearer idea of the different effects.
Explain your second point. I'm very, very curious.
As in, like, if there are 200 people, there will be like a different set of people, but you will want to like divide it into two groups, so randomization will help even more to diversify the different kinds of people you're experimenting with.
How does randomization help in diversifying?
Sir, because you're choosing randomly and not on basis of any category.
Excellent. Right? I love that answer. Now, one more
Okay,
person.
Shivansh.
Yeah, it was the same as you.
That's okay. Rephrase your
No.
answer in different words. I know you have your own set of words. You can rephrase your answer. Go on.
Yeah, so like the randomization basically like diversifies the groups and it also removes any bias which
Excellent. I love the answer, right? So in other words, what we're attempting to do using randomization is, in some sense, randomization is blind to all the confounders that I have. Remember, we were making a large fuss about how confounders are always going to mess up our analysis of trying to study the effect of the cause on the outcome, right? So the main idea behind randomization is that in some sense, it's blind to what the confounders are. The dice is not going to roll up as an even number for the richer people compared to the poorer people, for instance. The dice is not going to roll as an odd number for males more than females, for instance. Right? So this idea of randomization is in some sense a very, very clever way to control for the other factors that might affect the category or maybe like the previous history of patients and the actual recovery time from their fever, right? So this was the main idea of bringing in randomization as an attempt to understand the actual effect of the medicine on the outcome of the patient, right? So the main question that I answered is that I did not assign my treatment based on age or gender or how the patient feels or anything, right? And maybe as it was initially pointed out, if it's a new drug, then I may be very reluctant to take the Remediox, and so all 200 people might actually end up going to Crocin instead, which is going to be a very bad case scenario for me, right? So this idea of using randomized control trials is in some sense fundamental to try to understand the causal effect of one thing on the other, right? So it's often called the gold standard for causal inference. In other words, randomization is the best possible thing that we can do, right? But I have one question for you again. Do you think there are any issues with randomization? Are there any scenarios where you think I cannot apply randomization? Yes, Vikrant.
So there is a there's sometimes in randomization there might be a scenario where everyone goes to only one specific part and not the other part.
That can kind of be taken care of by having a pretty large sample, right? So, for example, instead of 200 people, if I recruit, let's say 6,000 people, for instance, then I would expect all 6,000 rolls of a die being odd to be very, very unlikely. There's going to be, I mean, I would expect at least one odd, one even roll in 6,000 rolls of a die. Do you see
The-
where I'm going with it? Yeah.
yes, sir, but still there might be a very small instance.
Excellent. Okay, that is a good thought. Right? Randomization in some sense might not necessarily take care of the problem of assigning treatment and control to equal populations. And what other issues do you see? That's a good answer. Thank you, Vikrant, for your answer. What other answers do you see? Who else has raised their hands? Sanjeev.
Yeah, Sanjeev.
So like the people who are being tested on wouldn't like to have their lives decided on a roll of a dice, so they might be rebellious.
Okay, sure. I like that thought. Okay. So in some sense, what are you getting to? You're saying that it might be slightly problematic to assign treatment based on just the roll of a die. Can somebody else think along these same lines and expand with this answer a little bit more? Let's say, what if I'm trying to understand a different scenario, for instance? But yeah, Kamal, let's say.
But in this case, some people might have allergic to the
I'm afraid I
remedial
can't
or
hear you very clearly, Kamal.
Kamal, your voice
yes,
is breaking. We can't hear you.
wait a minute.
No, I think while you work on your mic, so can you just try reworking on your mic and Madhusudan, what's your answer?
Sir, I have one. I want to make one assumption, so that's why I'm asking this question. Okay, the question is, won't they already be assigned to a group A and group B, the 3,000 people? Then won't the dice be rolled to choose who goes to the treatment group, who goes to the control group?
No, no. I decide which group they go to based on the roll of the die.
Okay,
Yes.
okay.
What's the issue with this? Okay, does anybody else have an do you, who was the other person who raised their hand? So somebody Malolan, was it?
Sir, it's a doubt. Uh,
Sure.
why would we? I don't get why we are doing randomization. Like,
Mhm.
why do we do that? It's
What's the alternate strategy?
yeah. Like, what is the use of doing that? I don't get it.
Okay, see, the idea behind randomization is the following. So let's say instead of randomization, let's say for each person, maybe like, so let's say there are 200 people. And for each of these 200 people, let's say I ask them whether they want Remediox or whether they want Crocin, right? The problem with asking each of them what they want is that my sample is going to become very, very biased, right? For instance, let's say the younger people are more adventurous and they're willing to try out Remediax, but the older people are going to be slightly more conservative in their choices, and they're going to say that I know that Crocin works, and so give me Crocin, right? So if such a thing happens, then what's going to happen? My treatment group is mostly going to contain very young people. My control group is going to contain mostly old people, right? And it is not very surprising to believe that it takes longer for fever to recover in older people than in younger people, right? So, what could be an unintended consequence of this is that I'm going to have very young people in my treatment group, and this they actually recover faster simply because they were young, not because they got Remediox. And in the control group where they got Crocin, there's a lot of old people, and old people in general, let's say, take longer to recover from fever. So the average length of time that they take to recover from fever could have actually been longer because they were old and not because they got Crocin, right? So by giving people a choice to decide which treatment they want, my sample in some sense is being biased, and I'm not able to understand the actual effect of Remediox as a means to cure fever. Do you see where that's going? Right? So that's one of the major issues with this, right? So what randomization attempts to do is randomization in some sense doesn't care about whether you're old or you're young, whether you're male or whether you're a female, right? Irrespective of all the factors about the patient, it's going to assign these people to the treatment and the control group randomly. This in some sense is the best that we can do in order to make sure that my treatment group and my control group are as similar as possible by just relying on the roll of a die, right? And I see a raised hand from Kia, was it?
Malolan, do you have the doubt?
Yeah. So, like, roll of a die is just simply like we can
Mhm.
just like randomly choose, right? Like,
Right.
but roll of a die will not be that perfect because
Mhm.
you can just normally pick, like, if this person's an old person, you take an old person, then you take a young person, and then one middle aged person. So it would be better to just pick by hand on
So
whichever person you want. That
I
would
would
make.
not. Okay, that's a very good thought, right? But the problem is, so here we're just thinking that age is the only thing that sort of affects my effect of my treatment, right? There may be many other factors. It's not just age, but also things like whether they're male or a female, for instance, or whether they're living in an urban area where they have access to clean drinking water. Are they from a rural area where they don't have access to clean drinking water? Or what their dietary or what their past medical history is. And are these people who already have a lot of comorbidities? Are these people who are very fit, healthy, and young? Are these people living in a place where there is a lot of pollution? Do these people, I mean, there are a whole bunch of issues in some sense that I have to control for. It's not just age that I have to worry about, right? In a sample of
but
size 200, yeah.
but how does roll of a dice solve this problem? Because that's very general. Like, it's just too
So
probabilistic.
sure, I see your point. The beauty of this is in the fact that it is too probabilistic. If I have a really large sample, then what? So there is you're going to maybe like when you take further courses in probability, you're going to see how things like this are taken care of by rolls of a die. In other words, let's say if I have 2,000 people, right? And or let's say I have 200 people, right? and let's say I roll a dice for each of these 200 people, then I would expect about 100 rolls coming up even for males, 100 rolls coming up even for females, and things like that. In other words, rolling a die in some sense is gonna uh, force itself to make sure that the two groups are actually similar in very different ways, right? I like this thought that you're having, but rolling a die in some sense is your best possible scenario to actually not force, but to get as close as possible to equally represented populations. Right? I really like your questions. I'll have some more time for questions towards the end once I get to what the actual problem of using randomized controlled trials is, right? So remember, what we'll be talking about. We were talking about whether there are actually any issues in trying to randomize, right? So, like all of you pointed out, so one of the things with randomization is that it need not always ensure that my two groups are as similar as possible, right? So I'm convinced that Malolan is still not convinced that randomization actually does anything good. But so there are many other issues with randomization, right? So for instance, let's say sometimes it may not be all that ethical to randomize, right? So let's say, for example, I'm trying to understand whether or not smoking actually causes cancer, or let's say whether I'm trying to understand something like whether wearing a seatbelt or a helmet reduces the risk of death in a major accident, right? In this case, if I were to use randomization, then what I would need to do is I would need to first carry out a sample. I would need to get about 500 people for a sample. And once I get these 500 people, I have to randomly decide whether I have to force them to smoke or not, whether I have to force them to not wear a seatbelt or not, right? In other words, randomization, when I'm trying to study some causal effects, randomization is something that could be extremely unethical to do, right? I should not have the freedom to force somebody to smoke. I should not have the freedom to tell people to not wear a seatbelt, right? So the issue with randomized controlled trials is I cannot always randomize, right? It's going to be unethical. It's going to be morally wrong, right? And like some of you pointed out, like Malolan is not Malolan, who is this? I forget the name, but sorry about that. But as somebody's pointed out, um, some of the groups may be underrepresented in the sample, right? In some sense, randomization is not the answer to it, but that's sort of it could possibly be close to the best that we can do, right? But now, what can we do instead of randomization? Sometimes we only have observational data, right? For instance, if I'm trying to study the effect of smoking, or if I'm trying to study the effect of wearing seatbelts, I cannot randomly assign who gets to smoke and who gets to wear seatbelts. And we only have data that we have observed. There is data of people who have smoked, who have cancer. There is data of people who did not smoke, who did not have cancer, and this entire two by two matrix, right? And there is also data, for instance, for who has worn seatbelts and gotten into an accident, who has not worn seatbelts and gotten into an accident, and so on, right? And the effect of the wearing seatbelts on their mortality. So in other words, we only have observational data for now, and we need to come up with even cleverer ways to use observational data, because in observational data, I would expect a lot of confounders to be there, right? So for instance, maybe like coming back to the idea of whether not wearing seatbelts actually increases the risk of death in an accident, we can argue things like younger people are going to be more risk taking and they're going to be not wearing seat belts. And does that mean younger people are more likely to die in accidents? Right? So there are questions like these that arise when we're just dealing with observational data. So we have to be very careful about how we're going to be dealing with observational data, right? So dealing with observational data is one of the major challenges of causal inference, where we don't have the power of randomization, right? So now, but now the next question that we can ask is, can we ever learn anything about whether or not wearing seatbelts can increase the risk of mortality in a major accident. Right? So questions like these about whether or not we'll even be able to answer these questions is one of the major foundational goals of causal inference, right? In other words, what are answerable questions and what are not answerable questions, trying to distinguish between the two, right? So in the interest of time, I'm just going to skip and maybe like in the last 5 minutes, spend some time talking about real world examples where causal inference is actually used, and then open the floor up to questions in the last couple of minutes, right? So where is all this actually being used? So I claim that it has a very, very, very vast set of uses, right? So for example, in the world of medicine, I can talk about whether or not using aspirin actually causes a reduction in the occurrence of a heart attack. And maybe questions like, do you think vaccines really reduce the infection or mortality rates, for instance, in the case of COVID or influenza or something like that, right? And maybe other questions that I can ask is maybe like more in the realm of public policy, where I can ask questions like, does it make sense to have a mandatory seatbelt and helmet law if it has been shown that wearing seatbelts and helmets actually reduces deaths in major accidents? And maybe things like, is it actually the case that having a small class size improves the test scores and the general cognitive ability of students in the later parts of their life? And maybe things like, does rural electrification cause an economic development? Does it make sense for me to, as a government, as a public policy expert, to invest a lot of money in electrifying houses in rural areas? Does it actually bring about an economic development? Or is there some other factor that it would be better to spend my money on in order to bring about economic developments in rural areas, right? And so these are like some major questions in the realm of public policy. And maybe some other miscellaneous question is things like, do you think social media is causing an increase in anxiety or depression or low test scores or things like that? And maybe questions like, should I have good environmental regulations? What good environmental regulations can I have without hurting growth? So in some sense, let's say for instance, I want to control pollution. So does it make sense to impose the odd even rule like in Delhi and ban firecrackers and things like that in an attempt to reduce my pollution without really having any unintended consequences which could potentially hamper economic growth, for instance? And maybe the idea of whether or not imposing higher taxes on sugar and junk food, is that going to make the population in general healthier, right? So these are like some of the broad questions that we can think about. And the goal of causal inference is, in some sense, to come up with methods to understand, uh, do do some of these policies that we're proposing, do they have an actual effect or not? If they have an actual effect, how much is the actual effect? Because everything at the end of the day is about money. So does it make sense to propose a major policy change in light of having this major causal relationship established? Right? So these are some of the broad questions that we're interested in. And like you've realized by now already, we're not just interested in if imposing taxes on sugar is going to reduce obesity, but we want to understand how much should the tax imposition be in order to get my obesity rate to reduce by a certain percentage. Right. So these are, I just wanted to expose you to the idea of some of the questions that people think about, and think about ways that people go about answering them, right? So this was one small exposure to this world of some of the problems that the world is currently facing, and an attempt to answer or alleviate some of these problems, right? So with this, I'll conclude like the formal part of the talk. I'll stick around for a couple of minutes for some questions if you have any. But yeah, so if you have any questions, raise your hand. And
Mm. Madhusudan, do you wanted to ask something?
No, sir. My
No.
question got solved already.
okay,
Okay.
good. Correct.
No one has the question.
Awesome. That is very good. I know this is like a late Sunday evening, but I hope this has been, I think, yeah, thanks to the organizers at first for like having me talk here. And yeah, so this was really fun. And I mean, I hope you have something interesting to take out of the session, right? And yeah, so that has been pretty good. So thanks again so much.
Thank you so much, sir, for
Okay,
taking
sir.
the session
Sir,
for us.
if you're done, can you take over to Swasti for the vote of thanks?
Yeah. Thank you so much, sir, for taking the session today for us. As you explained what correlation and causation is, causal inference, and a problem about introducing or convincing someone that a product actually works, and how and why randomization works. Yeah, thank you so much for taking the session. I think all of the students enjoyed it a lot. I could see them really reflecting and thinking about how to solve the problems we gave. And also a big thank you to the RAM team, the volunteers, and of course the students for attending and discussing.
Awesome. Thanks to the volunteers also, I think, for helping me massively coordinate with the questions. And I think, yeah, congratulations to all of you on finishing your RAM boot camp also. I hope you don't have sessions after this at 6 p.m. already. But
Yeah, this
congrats to all
is
of you
our
for
last
finishing.
session.
Sir,
Awesome. Okay, congrats to all of you.
can you share your email or contact
Yes,
so
I'll
students can
tell
talk
that
to you
right.
later?
My yes, I was planning to do that, but I forgot. Thank you. I have put out my email ID in the chat. You should be able to find that here. So awesome. Congratulations again on finishing another year of the Roots camp. And hopefully you come back in again next year and you're associated with RAM for the longest time you can. Thank you so much, then. Have a good night.
Bye, sir. Thank you.
Thank you,
Thank
sir.
you, sir.
Thank you. Bye, sir.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you,
Thank you,
sir.
sir.
Thank you, sir.